First question, bag A contains balls numbered. So A contains balls numbered 2, 4, 5, and 8. B has balls 1, 3, 6, 8, and 8. And C has balls 2, 7, there are 4 8s, and then a 9. And the first part, they're saying that find the probability that exactly 2 of the selected balls have the same number. So 2 of the selected balls should have the same number. So that's possible if from bag A we get number 8, 8 from bag A and 8 from bag B. That means P of 8 from bag A, 8 from bag B, and then not 8. We can write it as 8 bar for not 8. This is the first case because it has to be exactly 2, not at least 2, exactly 2. So there can't be more than 2. So one case is this. The second case, can be if the bag B again has number 8 and bag C has number 8 again and bag A has not 8. So for that, bag A has not 8, bag B has 8, and bag C again has 8. The third possibility, is that bag A has 2 and bag C has 2, whereas bag B does not have 2. So bag A has 2, bag B does not have 2, and bag C has 2. And then the fourth possibility will be if bag A has 8, we've done bag A has 8 and bag C has 8, but bag B does not have 8. So bag A has 8, bag B does not have 8, and bag C has 8. So these are the only 4 possibilities in which we can get exactly 2 balls with the same number. So we'll find the probabilities for each of them and then add them all together to find the total probability. So for the first case, probability of 8 from the first bag is 1/4 times from the second bag, there are 2 8s out of 5, so 2/5. And from C, we don't have to get an 8. So out of the 7 numbers in C, 4 are 8 and 3 are not 8s. So it will be 3/8. This is equal to 3/80. 3 upon sorry, 7. There's total 7 numbers, balls in bag C. For the second one, bag A does not have 8, so it would be 3 possibilities out of 4. For bag B, it will be 8, so 2 out of 5. And in bag C, again, 8, so those are 4 out of 7. This will be 6/35. For the third case, bag A has 2, so there is 1 2 in bag 8, so 1/4. times bag B does not have 2. All the numbers in bag B are not 2, so it will be 1, or you can say 5 upon 5 into bag C has 2. So out of 7, there is 1, 2 in bag C, so it's 1 upon 7. This is equal to 1 upon 28. Then for the fourth one, bag A has 8, so 1 upon 4. Bag B does not have 8, so 3 upon 5. And bag C has 8, so 4 upon 7. This is 3 upon 35. Now we'll add them all to get the final answer. So 3 upon 70 plus 6 upon 35 plus 1 upon 28 plus 3 upon 35. This is equal to 47 upon 140. So the answer to the first part is 47 upon 140. Okay, so we've done the first part. Now in the second part, it says given that exactly 2 of the selected balls have the same number, find the probability that they are both numbered 2. Okay, so this is the case of the conditional probability. Conditional probability के लिए the formula that we use is P A slash B, where B is the case that is given and A is the case that you have to find, is equals to P A intersection B upon PB. So, sorry, PB. So over here, A will be, A is that both number 2, both the balls that are the same are number 2. So that means that same balls number 2. A same balls should be number 2. And B is that 2 of the balls have the same number. So probability of B we found in the first part. So we know that what probability of B is, that is 47 upon 140. Now we have to find the probability of A intersection B. So A intersection B. This means that the ball selected, the 3 balls out of the 3 balls selected, 2 were the same, and those 2 were both number 2. So this was the case when from bag A we got 2, from bag B we did not get 2, and from bag C we got 2. So for that the probability would be 1 upon 2, because there is 1 2 out of 4 in A. 1 upon 4, sorry, out of 4 there is 1 2. From bag B there has to be any number except 2, so it's 5 upon 5 because all are not 2. And from C it has to be 2, there is 1 2 out of 7, so 1 upon 7. This is 1 over 28. So using the formula, the probability of the answer that we would find will be probability A intersection B upon B. So 1 upon 28 upon 47 upon 140. This is equal to 5 over 47. So second part is 5 over 47. In the third part, they're saying that event X is exactly two of the selected balls have the same number. So event X is that two of the selected balls have the same number. This is again what we found in the first part, is the probability will be 47 upon 140. Then event Y is the ball selected from bag A has number 2. So from bag A, the ball has number 2. They're not saying anything about bag B or C. So for Y, the probability will be from bag A, it has to be number 2. That means 1 upon 4. From bag B, it could be anything. So 5 upon 5. And from bag C, again, it could be anything. So 7 upon 7. This is 1 upon 4. Plus 5 and 5, 7 and 7 get cancelled. So we know now what are the probabilities for X and Y. Now they're saying, showing a working, determine whether events X and Y are independent or not. So for events to be independent, Px intersection Y should be equal to Px times Py. So we'll see if this is equal. If it is equal, then they will be independent. If it is not, then they will not be independent. So Px we know is 47 upon 140. Py we know is 1 upon 4. Now what will be Px intersection Y? So X is that both two of the balls selected have the same number, and Y is that the ball selected from bag A has number 2. So if both the balls have the same, two of the balls have the same number, and from bag A we get number 2, so then it will be the case जहाँ पे bag A had the number 2, bag C had the number 2, but bag B did not have number 2. So उसके लिए the probability was 1 upon 4 because we select 2 from bag A. Then from bag B we select any number because there is no 2, and from bag C we select 2 again, so 1 upon 7. So this is 1 upon 28 on the left side. On the right side, we're getting 47 upon 140 times 1 upon 4. So this is 47 upon 560. So since these are not equal, so not independent. That's the first question. Okay, so second question, a triangular spinner has one red side, one blue side, and one green side. The red side is weighed. Okay, so over here there is a biased spinner. It's not fair. The red side is weighed so that the spinner is 4 times more likely to land on the red side than on the blue side. So this means that probability of red will be equal to 4 times the probability of blue, because it is 4 times more likely to land on the red side than the blue side. Then they're saying green side is weighted so that the spinner is 3 times more likely to land on the green side than on the blue side. So probability of green will be equal to 3 times the probability of blue. And then in the first part, they're asking for the probability of the spinner landing on the blue side. So if we consider probability of the spinner landing on the blue side as X, so if I say that probability of B is X, so I can replace probability of B in these two equations by X. So I can write these as 4X and 3X. Now, since the spinner only has 3 sides, so it either has to land on blue, green, or red. So the probabilities of the 3 events are exhaustive. They will add up to 1. So X plus 3X plus 4X should be equal to 1. This means 8X is equals to 1. So X is 1 over 8. And since we know that probability of B is X, so probability of B is equals to 1 over 8. That is what they had asked us to show in the question. So from this, we know that probability of blue was X, that is 1 over 8. Probability of red was 4 times this. So that becomes 4 times 1 over 8, that's 1 over 2. And probability of green was 3 times probability of blue. So its probability of green is 3 times 1 over 8, so 3 over 8. On the second part, they're saying the spinner is spun 3 times. Find the probability that it lands on a different colored side each time. So it has to land on a different side each time. So you have to find the probability of all colors being different. So one case could be that in the first spin there's blue, in the second spin there's red, and the third spin there's green. Then there could be plus first is blue, second is green, and third is red. So like this, there are multiple possibilities that are there, and you have to add them all up. So instead of writing all of the possible outcomes, because there might be a lot of them, we can just arrange, you could just arrange these using a permutation and multiply that with the result to get the probability of all the possibilities, which will include all the possibilities. So what I'll do over here is I'll just multiply this with 3 factorial because there are 3 options and they're being arranged. So it will be multiplied by 3 factorial. This will give all the possible outcomes. So 3 factorial means 6. So this means that there are 6 possible outcomes, which are, there could be, for the first one we've written is blue, red, green. Then there could be blue, green, red. There could be red, blue, green, red, green, blue, and then green, red, blue, green, blue, red. So this 3 factorial has included all these options. So this makes our work easier. So this will be equal to 9 upon 64. So question 3. In this, there's a group of 30 teenagers. Of these 30 teenagers, 13 are male and 18 are male and 12 are females. From the 18 males, 13 watch a show called Cop Circuits, and out of the 12 females, 3 watch the show Cop Circuits. In the first part, they're saying find the probability that a person chosen at random from the group is either female. So we have to find the probability for either female or watches Cop Circuits and representing Cop Circuits as K, or both, matlab female and Cop Circuits. So we'll find the probability that the person is a female, then the probability that they watch Cop Circuits, and the third for female and Cop Circuits, and then add them all up. So for female, there are 12 females from the 30. So 12 upon 30 plus the probability for watching Cop Circuits. There are 13 males and 3 females. So the total 16 people watch Cop Circuits. So out of 30, 16 watch Cop Circuits. And then lastly, for female and Cop Circuits, there are 3 who are females and watch Cop Circuits. So 3 upon 30. Sorry, there's the mistake. There'll be a minus sign over here. So the reason is that For example, if we deal with this using sets, so if this is the set of females, this is the set of females, and this is the set of people who watch cops are kids. So when we add, basically this gave us the probability of all females. So it gave us this shaded region. And then when we found this, the probability of people who watch cops are kids, it gave us this whole region, the shaded region. So the central wala jo intersection tha, that got repeated twice. So we'll have to subtract that to find the final answer, find the final probability of people. If we subtract that, so we'll just get this whole part. So to remove the overlap, we'll be subtracting -3 upon 30 because it already got included twice. I hope it makes sense. So then the answer will be 12 plus 16 minus 3. So 13 plus 12 is 25 upon 30. That is 5 upon 6. Now for the second part, showing your working, determine whether the events the person chosen is male and the person chosen watches cops are kids are independent or not. So again, for independent events, this statement is true that probability of A intersection B should be equal to probability of A times probability of B. So probability of A intersection. So over here, let's say A is the person chosen is male and B is that the person chosen watches cop circuits. So the probability of A will be that the person chosen is male. So the probability should be 18 upon 30 because there are total 18 males out of 30. Probability of B that they watch cop circuits. There are 13 males and 3 females. So total 16 out of 30 people watch cop circuits. We got PA and PB. Now you have to find the intersection of them. So for the intersection, that means that males who watch cop circuits, there are total there are total 13 males who watch crop circuits out of the 30 people. So PA intersection B will be 13 on 30. That is the males who watch crop circuits. Now, for the event to be independent, 13 upon 30 should be equal to 18 upon 30 times 16 upon 30. So 18 upon 30 times 16 upon 30. And this is not true. This is not equal, so it's not independent. Next question, question 4. So they're saying that a factory makes a large number of ropes with lengths either 3 meter or 5 meter. There are 4 times as many ropes of length 3 meter as there are ropes of length 5 meter. So from this part, we can infer that the probability of 3 meter ki rope is 4 times the probability of 1 meter ki rope, 5 meter ki rope, sorry, probability of 5 meter ki rope. So if I say कि 5 meter की rope की probability is x, the m is meters, so उसकी 4x हो जाएगी, probability of 3 meter will be 4x. So x plus 4x should be equals to 1. So x is 1 upon 5 and then 4x will be 4 upon 5. So probability of 3 meters is 4 upon 5 and for 5 meters it's 1 upon 5. So we found that this is 1 upon 5 and this is 4 upon 5. Now, In the first part, one rope is chosen at random, find the expectation, the expected value, and the variance of its length. So for this, I'll use the probability distribution table. First, I'll draw the table. We don't need this necessarily, but it will make work easier. So this is X, this is probability. The first possible value is 3 meters, the second is 5 meters. For 3 meters, the probability is 4 by 5. And for 5 meters, it's 1 by 5. So now for the expected value, we need expected value ka formula is Ex is equals to sigma xp. So we need the sum of all x into p. So the first one will be 3 times 4 upon 5. There are only two such values. So the second will be 5 times 1 over 5. So iska answer will be 12 upon 5 plus 1, 3.4. This is the expected value. Variance in the probability distribution table is equals to sigma x square p minus expected value. So for x square p, sigma x square p, first one will be 3 square times 4 upon 5. 3 square is 9. So 9 times 4 upon 5. Plus second one will be 5 square, that is 25 upon 5 minus 3.4. So 9 4 are 36 upon 5 plus 5 minus 3.4. This is coming sorry, expected value का it's square. So इसका square होएगा minus 3.4 square. So this is coming 0.64. Variance of x is coming 0.64. So yeah, that is the first part. Expected value and variance. Now for the second part, two ropes are chosen at random. Find the probability that they have different lengths. So probability of 3 meters was 4 upon 5, and the probability of 5 meter was 1 upon 5. They're saying that the two ropes chosen have different lengths. So it could be that there's first 3 and then 5, or there's first 5 and then 3. These are the two possibilities. So for 3 and then 5, it will be 4 upon 5 into 1 upon 5. For 5 and then 3, it will be 1 upon 5 times 4 upon 5. This is equal to 8 upon 25. In the third part, they're saying 3 ropes are chosen at random. Find the probability that their total length is 11 meters. So we have 3 meters and 5 meters. Okay, first, I'll write the probability of 3 and 5. This is 4 upon 5. And for 5, it is 1 upon 5. So we have 3 meters and 5 meters. So what are the possible combinations that will make the total length 11 meters? So it might be 3, 3, and then 5. If there are 3 3s, it would be 9. If there are 2 5s, it would be more than 11. So this is the only possible combination. But there are many possible multiple possible arrangements of this. So we'll find the probability for 335 and then we'll multiply it with the possible arrangements. So probability of 11 meters की length in 3 tries in 3 chooses of ropes are that the first is 3, so that would be 4 upon 5. Second is 3, so again 4 upon 5, and then third is 5, so 1 upon 5. Now for arrangements, there are 3 objects that we have to arrange, but 2 of them are repeated, so we'll divide 3 factorial by 2 factorial. This will be 3 factorial upon 2 factorial will be 3. So the answer is coming 4 upon 125 3. 16, 48 upon 125. That's the fourth question. So question 5, Maria has 3 preset stations on her radio. When she switches her radio on, there is a probability of 0.3 that it will be set to station 1, probability of 0.45 for station 2, and a probability of 0.25 for station 3. On station 1, the probability that the presenter is male is 0.1. On station 2, the probability that the presenter is male is 0.85, and for station 3, it is P. When Maya switches on the radio, the probability that it is set to station 3 and the presenter is male is 0.075. Okay, so over here, basically it's becoming a sequence that station 1 aega, and then after that there is a possibility of male and then female. Station 2 pe again possibility of male and female. So this question can be done using a tree diagram. So I'll draw a tree diagram for this. Pehle, there are 3 possibilities. So first, the 3 possibilities are station 1, station 2, or station 3. Station 1 की probability was 0.3. Station 2 की was 0.45. Station 3 की is 0.25. उसके बाद station 1 के अंदर there could be a male presenter or female presenter. Station 2 में same. Station 3 में same. So station 1 में male, female, male, female, and then male, female. Station 1 के अंदर male की probability is 0.1 if I'm not wrong. So female की will be 0.9. 1 minus 0.1. Station 2 के अंदर male की probability is 0.85. Female की will be 1 minus 0.85, that is 0.15. Station 3 में male की is P and female की is 1 minus P. Now they're saying that when Maya switches on the radio, the probability that it is set to station 3. So पहले तो there is station 3 हो गया, and the presenter is male. So station 3 आया and presenter is male. So station 3 and presenter is male. So to find the probability of this case, what I would have done was I would have multiplied 0.25 with P. This should be equal to 0.075, they're saying. So we can use this to find P. P will be 0.075 on 0.25. That is 0.3. So yeah, it's 1 mark, but again, doing it without the tree diagram might be difficult. The tree diagram makes it easier, but there are no marks for the tree diagram because you're not asked in the question. Now to the second part. So for the second part, they're saying given, again, the word given, so it is conditional probability over here. Given that Maria switches on and hears a male presenter. So when she switches it on, she hears a male presenter. And find a probability that the radio was set to station 2. So the condition was that there is male presenter, and then we have to find if it was station 2. So I'm writing the formula for conditional probability again. So it's basically P A given that B, probability of A given that B should be equal to probability of A intersection B, A and B upon probability of B. So over here, B is that there's a male presenter, and A is that it's station 2. So probability of A intersection B will be, okay, it's station 2 and male. So 0.45 times 0.85. For probability of B, there are 3 possibilities. There's station 1 and then male. That's 0.3 times 0.1. Second is second is station 2 and male. So 0.45 times 0.85. Third possibility is that station 3 and male. So 0.25 times P. P we found in the last part was 0.3. So simplifying this, this is equal to 0.785. That's question 5. So now question 6. So there is a spinner which has 5 sides numbered 1, 2, 3, 4, and 5. When the spinner is spun, the score is the number of the side on which it lands. The score is denoted by the random variable x, which has the probability distribution shown in the table. So over here, we can see that for each side of the spinner, there is a different probability. Okay, it's a biased spinner, not a fair spinner. And over here, because the spinner has only 5 sides, so the probability of the 5 sides should add to 1. It's an exhaustive event. So 0. For the first part, 0.3 plus 0.15 plus 3p plus 2p plus 0.05 should be equal to 1. So it's 0.3 plus 0.5 plus 5p equals 1. So 5p equals 0.5 and p equals 0.1. So p we found 0.1, that is the first part, 1 mark. So for 3 it's 3p, so it will be 0.3, and for 4 it will be 0.2. 0.1 into 3 and 0.1 into 2. Then they're saying that there's a second spinner which has 3 sides numbered 1, 2, and 3. The score when the spinner is spun is denoted by the random variable x. It is given that there's a probability for x, the second spinner landing on 1, on 2, and on 3. So I'll first draw a probability distribution table for y. So there are 3 possibilities. So we'll have 3 columns. This is y. This is the probability. So 3 possibilities are 1, 2, and 3. First के लिए है 0.3, 0.5, and 0.2. Now let's see what they're asking for. So find the probability that when both spinners are spun together, the sum of the scores is 4. So the sum has to be 4. For that, we'll see all the possibilities, find the probabilities, and add them up. So it's 2 ka first part. The sum is 4. So the sum can be 4 when x ke upar, if there's 1 on x, then there has to be 3 on y. This could give 4. Then if there is 2 on x, there should be 2 on y. If there is 3 on x, there should be 1 on y. And there can't be 0 on y, so we can't take 4 or 5. Now find the probabilities for all of them and add them up. So for the first one, probability of 1 and 3. So 0.3 times 0.2. 0.3 यहाँ से आया, 0.2 यहाँ से आया. Second के लिए 2 and 2, so 0.15 into 0.5. Third के लिए 3 and 1, so 3 के लिए we was 0.3, 3 times 0.1, this, and 1 के लिए it's given 0.3 again. So we'll find these. The first one is coming 0.06. Second is coming 0.075. Third is coming 0.09. Now adding them all up, 0.06 plus 0.075 plus 0.09 is coming equal to 0.0 0.075. This is coming equal to 0.225. So again, I'll just label which value came from where. So for the first one, there was 1 from x. We got 1 on x and then 3 on y. So 1 on x is 0.3 and 3 on y is 0.2. So that's why 0.3 into 0.2. For the second one, 2 and 2 on both. So 2 का 0.15 था x पे and 0.5 था y पे. So 0.15 into 0.5. Here third वाले का it's 3 on x and 1 on y. 3 on x we found 0.3 and 1 on y was 0.3. So 0.3 into 0.3. And then we just added them all up. So we got the answer. Now the second part. Now they're saying that when both the spinners are spun together, the product of the score is less than 8. Okay, so for this, if there's 1 on the first dice, on the first spinner, then there can be 1, 2, or 3, any of them. How do I write this? Writing any. 1, 2, or 3, any of them, because 1 into 1 is 1, 1 into 2 is 2, and 1 into 3 is 3. They're all less than 8. Second, if we take 2 from the first one, then again, there can be any. 2 into 1 is 1, 2 into 2 is 4, 2 into 3 is 6. Third case maybe if 3. So 3 into 1 is 3, 3 into 2 is 6. We cannot take 3, we can take 1 or 2. So I'll write this as 1 or 2. So third, if we take 4 from x, then we can take 1. It has to be less than 8. So we can only take 1. We can't take 2 as 4 2s are is 8. So we can only take 1. Fourth possibility is so that's 0.3 times 1. For the second one, there's 2 on from x. So 2 ka from x is 0.15. So 0.15 from y there can be any. So 1 ho jayega y ke liye. For third wala, there's 3 from x. So 3 from x ka 0.3 we found. So 0.3 from y, it could be 1 or 2. So 1 or 2 की probability is 0.3 plus 0.5. That's 0.8. क्या हुआ? Okay, for the third one, 0.3 into 0.8 is 0.24. For fourth one, 0.2 to 0.3 is 0.06. And this is 0.05 into 0.3, that is 0.015. Now adding them all up, 0.3 plus 0.15 plus 0.24 plus 0.06 plus 0.015 gives 0.765 as the probability for the product to be less than 8.